Hello, my name is Patrik and I work as a product specialist for the bin picking studio here at Photoneo. Today, I would like to introduce new features of the recently released bin picking studio version 1.6. The new version is packed with features that will improve your user experience and increase your productivity. Come and join me in the demonstration of bin picking studio version 1.6. It's been some time since we introduced the concept of vision systems, which ties together a number of things: the scanner, the robot camera calibration, the picked object and the localization profile, and several other settings. In each release of the bin picking studio, we try to build on that and further expand its capabilities and possibilities of use. When using multiple vision systems for picking objects of various shapes or using bins of different types, we might not find the same picking strategy optimal for all of them. With bin picking studio 1.6, this problem becomes irrelevant. We introduced the feature called multiple grasping methods. Now you can define several picking strategies and choose which one should be tied with each vision system. Let's illustrate that in a practical example. Suppose we have two types of objects we want to pick, placed in different bins. One object is considerably larger in comparison to the bin size. The bin is also deep, which makes the picking of such an object from the bottom of the bin a bit complicated, as there is not much room for maneuvering. After grasping the object, we will want to move vertically upwards in a linear path until the object is outside of the bin. The default option, a fixed length of the D-approach trajectory, is not suitable in this case. The D-approach waypoint for the objects at the top of the bin would be outside of the robot's reach. Therefore, we define the D-approach waypoint at a fixed height from the robot base. The other object is small, placed in a shallow bin with its upper edge much lower than the upper edge of the deep bin. Using the same grasping method as for the first object, the D-approach waypoint would be too high, which is pointless. Here, the default grasping method, where the D-approach waypoint is defined at 10 cm above the gripping point, will suffice. This way, we optimize the grasping method for each vision system. Accurate robot-to-camera calibration is an essential part of the bin picking application. The calibration procedure needs to be carried out every time the relative position of the robot and the scanner is changed, which happens especially during the early stages of integration, but on rare occasions even during production. It is a good idea to have the calibration poses of the robot saved in the robotic controller to speed up the process. And although it takes just a few minutes, we sought to automate the calibration procedure even more. From now on, the robot itself is able to add calibration points using a new function call, an action which up until now was taken care of by the operator every time the robot reached a calibration pose. Now the operator just initializes the calibration procedure inside the bin picking studio, starts the program on the robot, and verifies the result once the program has finished. During bin picking, the robot usually needs to move only in a fraction of its joint range. We always strongly recommend setting up joint limits so that the path planning is taking place only in a subspace of the robot's full workspace. Joint limits that are set up correctly have a positive effect on path planning, computation time, and, of course, picking success rate. It can be difficult to picture the final workspace. To help you with that, we implemented visualization of the robot workspace on the environment page. The robot should be limited in such a way that only the bin and the space above it are in the workspace. After adjusting the joint limits, simply hit the Generate button to render the new workspace of the robot. Version 1.6 of the beam picking studio marks our first step towards beam picking in a simulated environment. The ability to simulate the behavior of a potential beam picking application brings many advantages, from easier and faster decision-making to reduced overall integration time and costs. This first iteration of the simulation feature brings the option to call standard robot requests directly from the deployment page of the beam picking studio. To be able to deploy the solution, it needs to be fully configured, including having the vision system calibrated. After that, this mode is ideal for the initial testing of path planning performance and tuning of parameters. There's no need to have the robot connected at all. Actually, if you want, you don't even need to have the scanner connected. You can save some scans from the scanner and create a file camera for offline use. And using the file camera feature, the recorded scans will be looped indefinitely. This way you can fine-tune the solution even off-site. You can also transfer the solution and file camera to another vision controller and continue your work there. When in simulation mode, the deployment page displays an interface for calling the basic robot requests. You can easily initialize the start and the end pose for path planning and start triggering scans either from a real scanner or a file camera. You can even request a trajectory to test the prioritization options. Simulation mode is also suitable for testing different gripper designs off-site. Once you are satisfied with the beam picking solution, you can continue with commissioning on the real robot. One of the key parameters of every production line is the cycle time, which helps you get a better insight into the overall performance of your application. Beam Picking Studio 1.6 brings cycle time monitoring directly onto the deployment page in the form of a bar chart. Cycle time is measured on the vision controller and it represents the amount of time that passed between two consecutive robot requests of the same type. You may choose whether that is the trajectory request or the scan request. To check the exact time of a specific cycle, just hover over its sample to display the details. The average cycle time in the top right corner is computed from all currently visible cycle time samples. To improve the performance of your beam picking application, it is crucial to be able to see and understand what is happening inside. The inspector feature has been a part of the beam picking studio for several years now, and we strive to make it better with each update. We are adding the option to choose which gripper model is displayed, either the STL model or the volumetric one, that is automatically generated from the provided STL. You will want to use the volumetric representation while previewing the grasping waypoint when it failed to be computed because the amount of gripper in collision exceeds the allowed value. It is in fact the volumetric model that is used for collision checking during the grasping of the object. This enables more accurate visual inspection. We also focused on overall system improvements and speed up of the beam picking studio. Thanks to the software optimization, we managed to significantly reduce the amount of time it takes for some actions to complete. For example, the changing of the deployed solution is now much faster. Beam Picking Studio 1.6 also comes with the latest machine vision software by Photoneo, the Foxy control and the localization engine, which have been improved as well. The last but not least is the remote access feature. Beam Picking Studio is a web-based application. It is running locally on the vision controller, but from now on it is fully accessible from another device out of the box. Just connect the vision controller to your device or a local network, set up a static IP address on the network interface, and you are good to go. On your remote device, open your web browser and type the IP address into the URL field. Now you have full access to the Beam Picking Studio, which is especially useful for remote monitoring. Thank you very much and see you soon.